rule is when you have something inside a bracket to an exponent. So for example, power rule, what we've had is this is not chain rule, power rule. An example would be like y equals 1 over x to the 3, right? Nothing's embedded in that x, it's just x to the 3. So then we would write that as x to the negative 3, and y prime would be negative 3x to the negative 4. We had that. We had product rule where we have two basic things multiplied together, right? And we talked about e to the x, yes? But what we're going to talk about today is we're going to talk about more chain rule when we have a numerical base to a variable exponent. That's one of the power chain rules. And then the other one is if we have something embedded. So that's our power rule thing. Then we had product rule. Where we had like y equals 3x times x plus 2. This would be our f, this would be our g, and then we did g f prime plus f g prime. And then we had quotient rule. Where you have y equals x over x minus 7 or something like that. This would be f, this would be g, and then it would be g f prime minus f g prime over g squared. Right? Those are the three things we've learned. What we have not learned is chain rule. So chain rule, you end up getting things that are like chained together. Chained together meaning like bracketed beside each other. When something is bracketed beside each other, it's multiplied. Okay? So an example, the first type of chain rule is numerical base to variable exponent. That's the first type. Numerical base to variable exponent, and it's the one that everyone kind of forgets about. So when you get a numerical base to a variable exponent, let's say it's like this. I could use a variable, but that throws people off because it'll be a variable to a variable and then you get confused. Let's say this is a numerical base to a variable exponent. A prof would say a to the x, where a is an element of the integers or something like that. Okay? When you get that, y prime will be rewrite, so the number to the variable exponent, so rewrite it. That's the first chain. Then the second chain is ln the base, ln the base. And ln, just so you know, ln is the same as saying log base e. It's the same thing. So ln is just log base e. Just like if I write log and I don't put a base on it, that's base 10 because it's one of the most common logs. Base e is also another common base for a log, so they write it as ln instead. And then the last thing you do is derivative of the exponent. So in this case it would be 1. So do you see how there's 3 chains every single time? When you have a numerical base to variable exponent. We've always dealt with, so far, variable bases to numerical exponents, like x squared, x to the 4, x to the 5. We can do those using power rule. But when your base is a number and your exponent is a variable, you have to use chain rule. Rewrite it, ln the base, derivative of the exponent. Okay? So, we're going to derive some functions. So, we're going to say determine the derivative of. Like I said, today's a pre-teach, so that when you go through the notes, they're not overwhelmed, right? Because the AP stuff itself can be overwhelming. So, A. Say I give you y equals 4 to the x. We're going to do an easy one. So we have to be able to spot these and know that this is a chain rule. A lot of people will spot these and not know what to do with them. So we have a numerical base to a variable exponent, correct? A number to a variable exponent. So when we get that, y prime is 3 chains. The first chain is to rewrite it. The second chain is to ln the base, so ln4. The last chain is the derivative of the exponent. What is the exponent? Yeah, derivative of it is 1, because the exponent is x. So you don't have to write that 1, so it's 4 to the x ln 4. Sometimes they write ln 4, 4 to the x. Doesn't matter, it's multiplication, right? So they can be any order. Okay. B, what if I give you y equals 5 to the 3x squared minus 2x plus 6? Still, numerical base, 2 variable exponents, correct? That has not changed. So, to find y prime, the first step in the chain, there's always going to be three chains when you have a numerical base to variable exponent. The first step is going to be to rewrite it. So we're going to get 5 to the 3x squared minus 2x plus 6. Oops. Then my second step is lnning the base. So I'm going to get ln of 5, which is a decimal, so it just stays ln of 5. And then the last one is derivative of the exponent. So if I have 3x squared, it's going to be 6x minus 2. Now, a lot of the time, just so you know, they will go one more step. They will look at that 6x minus 2 and say, I can take a 2 out of it. So they'll write it as 2 bracket 3x minus 1. So they'll take this, move it to the front, and take a 2 out of it. You see that what I did there? And then they'll go 5 to the 3x squared minus 2x plus 6 ln 5. Does the order in which we write these chains matter? Chains are being multiplied, correct? Does order of multiplication matter? No. You could write them out of any order, and I can't take any myself. Okay? Okay. C. You try this one. So, I'm going to rewrite the exponent in a form I can use. Remember, if you have radicals, you always write them as rational exponents. And if you have denominators which are with x in it, you write them up as a numerator. Now you have to do quotient rule. So here we get x to the 2 over 2, which is just x. Whoa, don't know why I put the plus sign down there. Plus 6x to the negative 1 minus 4x to the 5. So f prime of x is going to be rewrite it. I could leave it as the beginning if I wanted to, or like this. It doesn't really matter, right? And then ln of the base, ln of 8, and then derivative of the exponent is 1 minus 6x to the negative 2 minus 20x to the 4. All right. Okay. D. What if I give you this? G of x equals e to the x. E to the x or pi to the x. People won't often spot e to the x especially as a variable base to, or a numerical base to a variable exponent. Remember, e is 2.7181, blah, 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 just like pi is 3.1415, blah, 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 blah. Okay? So, it is a numerical base to a variable exponent, and e to the x is a special one. So watch. G prime of x, the first step is to rewrite it. Ln the base, ln of e, and then the derivative of the exponent is 1. Now, please look over here. So ln of e. Ln of e is what? Why? Because it's log base e to the e, which is 1. So that becomes a 1, that becomes a 1. So remembering that the derivative of e to the x is e to the x. It's the only numerical base to the variable exponent that is actually the same. Okay? E, if I give you e being, let's say g of s. Everyone loves s because it looks like 5, so this is what I do to challenge the people who are messy. All right. Negative e to the s squared minus 4s plus 6. Okay. What I want to show you is if you have a term with a coefficient, like this e or whatever, it's a negative e, your first step is going to be to write it as a negative e. We'll leave it as a positive for now because I'm going to completely destroy you guys if I, let's just leave it as a positive e for right now. We'll get to the negative. Okay. So, if we go to do the derivative of this one, g prime of s equals, rewrite it, ln the base, ln of e is what? 1, so that goes away, but we do have the derivative of the exponent, right? So e to the x is the only one that says e to the x. E to the anything else, you have to do the derivative of the exponent. So we're going to get 2s minus 4. I can take that 2 out. I get g prime of s equals 2 s minus 2 and then e to the s squared minus 4s plus 6. Now these can be asked just like everything else that we have asked. So I can ask you for the derivative of this, which means I can also ask you for the tangent slope at a specific point, which means I can also ask you for the equation of the tangent line at a specific point, or the normal. Okay? So, let's go to a basic one. Example 2. So, given y equals 4 to the x squared, determine the equation of the tangent when x equals 1. Equals 4 to the 1 squared, which is 4. So I know my coordinate is 1, 4. And that's going to be my x1 and my y1. Then I need my m tangent. My m tangent is a fancy way of saying what? First derivative. So it's numerical base to variable exponent. We rewrite it. Ln the base. Derivative of the exponent. And then I have to plug in a 1. Correct? Because this is the general m tangent. So it's going to be 4, 1 squared, times ln of 4, and then 2 times 1. So it's going to be 8, because it's 4 times 2, 8 ln 4. That can't get any prettier, no matter how much you want it to get prettier. Right? Because 4 to the 1 is 4, 2 times 1 is 2, 4 times 2 is 8 ln 4. Then our formula is y minus y1 equals m times x minus x1. So it's going to be y minus 4 equals 8 ln 4 x minus 1. Done. So it really isn't that terrible. But it looks terrible. Oh, wait. Example 3. Okay. Quiet, please. Determine the equation to the normal. Just need to flip your slope and change the sign, right? It's the only difference. The equation to the normal for g of x equals 5 to the x squared minus 2 when x equals 1. I'll be nice. So g of 1 equals 5, 1 squared minus 2. So what does it equal? 5 to the what? 5 to the, which equals 1/5. There we go. I agree. Okay. So we have 1 and 1/5. That's our coordinate. And that's our x1, y1. Okay. We need our m tangent. And then we can get our m normal. Remember how I talked about in grade 10, you get taught how to find the perpendicular slope? And the way you get the perpendicular slope is you negate whatever slope you have to make it run at the other direction. So if one is running positive, then the other would be running negative. Shame. All right. M tangent. So we rewrite it. Ln the base. Derivative of the exponent. And then we plug in a 1. So we get 5 times 1 squared minus 2, which we know is 1/5. Ln of 5, 2 times 1. So we're going to get 2/5 ln 5. This turns to 1/5, and this is a 2. 2 times 1/5 is 2/5, right? Okay. So that is the same as saying 2 ln 5 over 5, technically. And I want a full fraction because I want to be able to have the ability to flip that said fraction, correct? To get m normal. So m normal is the negative reciprocal slope because m normal is the perpendicular slope to that. That's why you get taught about perpendicular slopes in grade 10. Everything you're taught about 10, 11, and 12 is for calculus. It's called pre-calc. Okay? So we're going to get negative 5 over 2 ln 5. And then we get y minus 1/5 equals negative 5, 2 ln 5, which is just a lovely slope this time of year, x minus 1. So this is numerical base to variable exponent, right? That's what we do. The other chain rule is whenever we have something embedded to a power. So like only thing we've done so far is like x squared, 3x cubed, 5x to the 2/3, something like that. But what happens when I actually have something embedded? Join me. Okay, type 2. Something embedded in here to an exponent, like 5. That something embedded in those brackets can't be a monomial. So, if I had, like, for example, 3x squared minus 6x to the 5. So it's whenever you have not a monomial to a 5 or a 4. Whenever you get a binomial, trinomial, anything inside of there. We're going to have even trig inside of there at some point. Okay. So here we're going to say example 1. Guys, stop. Differentiate the following. So differentiate means to find the first derivative. So A, what if I give you this? Y equals 6x squared minus 4x. I'll do an easy one first, to the 3. Okay, when you do chain rule, you chain from the outside in. So you can't just do the derivative all at once. So some people tell me the derivative all at once. You can't do that. We're chaining, we're linking. So our first derivative is we have to work from the outside in. So the first thing we have to do is cover up the 6x squared minus 4x with our hand, or erase it because we got close to it with our hand. And we have to do the derivative of the outside. How do I do the derivative of something to the 3? The 3 drops in front, and it becomes something to the 2. Okay, so we're going to do that. Y prime is going to be 3. That's something to the 2. So just so you see that, that stayed the same, correct? Mm-hmm. What I get a lot of people doing is they'll go 3, write the derivative of that something in the middle to the 2. You're going to be wrong. We need chains. We wouldn't have any chains if that's how it was. So work from outside in. So the 3, rewrite it to the 2, and then we get a chain behind it. What do you think the chain behind it is? Yeah. It's the derivative of the inside function. Sometimes you can have chains inside chains. You can have something squared to something cubed to something. So we need to be able to do chain rule really easy because our F or our G in product rule could be a chain rule, right? So we're going to get 12x minus 4. And then what can I do with that 12x minus 4? Take a 4 out. So I'm going to get y prime equals 3, 6x squared minus 4x to the 2. Take out a 4, and I'm left with 3x minus 1. Is there anything else I could do? They will for the textbook do this, yeah. Can't because it's squared. Yep. Outside of 3 and the 4. You get 12, and then they'll often write the 3x minus 1 next, and they'll write the chain last. You can write them in any order you want, but that's often what they'll look like. Okay? Go. All right. F prime of x. Rewrite it. There's a half outside. Rewrite the inside. What's it going to be to the exponent of? What's it going to be to the exponent of? Negative a half. And then the inside is what? 18 x squared minus 8x. Too much talking. Okay. So, then we're going to take a 2x out, guys. Please be quiet. We take a 2x out, and then we're left with 9x minus 4. This 2 and that half cancel. So on the top, you are left with x, 9x minus 4, and then on the bottom, you're actually left with this to the positive half, or they might write it as square root of 6x cubed minus 4x squared plus 6. Depends on what the answer is. 2.5? Yeah, but you can, but the answer key might be that. No, they'll make them positive usually. The first was that A and B? I can't remember. So C. We want to differentiate these. I'm going to give you one with a numerical base to variable exponent times the polynomial. So f of x equals 4x squared times 2x cubed minus 6x. So I cannot just FOIL these and use power rule. I have to use product rule. What I need you to know about product rule is if we have a chain rule in a product rule, we'll be able to GCF it out. Because your first step will always be to rewrite that base, or the whole thing. So this here is a product rule. So this is my F, this is my G, and then I need to find F prime and G prime, correct? Because that's how I do product rule. So F prime is a chain rule. I'm going to rewrite it ln the base, derivative of the exponent. Fun times. Okay? Then your G prime is just power rule. It's 6x squared minus 6. And then if I want to, which I will, I can take a 6 out and I'm left with x squared minus 1. I haven't done the product rule at all yet, but I've set it up. Okay, I have an F, I have a G, I have an F prime and G prime. Correct? Then I just need to fill it into the formula. Remember, G in the textbook or any resource, it's going to say FG prime plus GF prime. But I will always do G F prime plus F G prime, because that's actually the top of the quotient rule with a minus sign in between. So I don't have to memorize two different formulas. If the product rule, falls out of your head, just remember that you need to multiply a derivative by the other one, normal, plus a derivative by the other one, normal. So like here I have GF prime plus FG prime, right? So a normal times the other derivative plus a normal times the other derivative. But I just memorize it. Okay. So F prime of x is going to be G F prime so that's one term. GF prime, that's one term, correct? Because they're multiplied together. Plus F times G prime. The first term in the blue, I'm going to actually take a 2x out of this. I'm going to simplify that bracket first before I try and take out GCFs. So I'm going to go F prime of x equals 2x, and then I'm left with x squared minus 3 times all this fun. 4x squared ln 4 2x. So instead of writing the 2x and the 2x like this, what could I just write in the front? 4x squared, technically, right? Erase that one, and I'm going to erase that one, and then I'm going to put them together as 4x squared. So I always try and simplify my terms as much as I can before I try to go GCF. So that's my one term, and this is my other term. So like I said, if there's a chain rule, you will always be able to take one of those out. Because if you look here, f has 4x squared in it, and f prime has 4x squared, 4 to the x squared in it as well, right? Because our first step of the chain rule is to rewrite it. So this is a great that we have it like this, but we do have to do one more step where we take out what is common to both of the blues. So what can I take out of both of the blues? 4 to the x squared. Can I take a 4x squared out of both? No. Can I take a ln 4 out of both? Can I take an x squared minus 3 out of both? The 4x squared, though, is a monomial, correct? And the 6 is a monomial. Can I take something out of both of those? A 2. So that's all I can take out. And then I will write a square bracket myself to write what's left over so that I know I'm just taking out a GCF. You could leave it as a round bracket, it doesn't matter. So in this first blue, when I take out the 4 to the x squared and the 2, what am I left with? 2x squared, yeah. And then the x squared minus 3 stays, and the ln 4. Right? Then the plus sign. Then if I take those out of the next blue, bless you, if I take a 4 to the x squared out and I take a 2 out, I'm left with a 3, and then x squared minus 1. That's it. I'm going to have you guys try one like this, and then we're going to do one where the chain rule is actually like binomial cubed or something like that, instead of a numerical based variable exponent. So you guys are going to try this one. So f g f prime is 4x, g prime is 8 to the 4x squared minus 6x, ln of 8 to the 8x minus 6, and then we're going to reduce that, take out a 2, and then we're left with 4x minus 3. Those are all our chains, right? Okay, so g prime of x equals g times f prime minus f times g prime. If you didn't notice, I gave you a nicer one than I did this example before. All right. What's the matter? Oh, that was aggressive. All right. So we ask ourselves, and I'll even highlight both sides if it makes it easier for you guys right at the beginning to show that there are two terms there, right? This is one term, this is another term. What can I take out of them? Well, I can take out that 8 to the 4x squared minus 6x, because we know it's going to be in both. And then I can take out a 2. Okay. So in the first blank, all I'm left with is an x plus, totally there, plus 2x cubed plus 3. Guys, stop talking. Ln of 8, 4x minus 3. Okay, I'm going to give you an E and an F and see how you do. These are different.